All right, so last two sections we're going to look at in Chapter 6, or 6.3 and 6.4. We skipped one section in Chapter 5. So that next academic week, I told you we have one section we're going to go back to. That's the section we're going to go back to. Okay. So this is it on exponents and that kind of stuff, though. So we're going to split 6.3 and 6.4 into four days. So we're going to go nice and slow through it. So when we write an exponential function, it has a formula to it, right? Just like when we write the equation of a line, that has a formula. What do we normally use for the equation of a line? It starts out y equals mx plus b, right? That's just the standard way, most common way we write the equation of a line. Well, when we write the equation of an exponential, it looks like this. Y equals ab to the x. So it still has a y, it still has an x. Those two letters, just like in y equals mx plus b. But we get these other two letters here, an a and a b. And we'll have to talk about what the a and the b mean. Okay? When I showed you guys some sample graphs on the calculator, I was playing around with the b number. And I kind of showed you what happened if it was bigger than 1, how you got one type of graph. And then if it was less than 1, you got a different type. So we're going to spend some time looking at that this week. Now, a can be pretty much any number that you want except 0, right? A can't be 0. Because think about what happens if you multiply something by 0. What do you get? Well, you can multiply by 0, but what do you get? You get 0, right? So if you multiply something by 0, it kind of wipes out everything. Well, that's why we can't do it. We can't wipe out everything, and we don't even have an equation anymore, right? So a, you might see a number like 2, you might see 4, you might see different numbers, okay? But you'll never see 0. Now, b. B is only going to be certain values this week. Specifically, it has to be a positive value. B can't be negative. Really weird things start to happen if B is negative. We're not even going to talk about that. And there's one positive value that you can't have for B, and that's 1. Think about what would happen if you put in a 1 for B and you raise 1 to a power. We did this during the warm-up. What happens if you raise 1 to a power? It just stays as 1. That's kind of a weird case, right? If you take and you multiply a number that's bigger than 1, like, oops, let's say we took like 1.5, and we keep multiplying it by 1.5, right? And then times 1.5, and then times 1.5. Okay? What's happening is it is getting bigger, right? It's getting bigger and bigger each time. If I take a number like 5, and I multiply it by 1/2, what happened to it? It got smaller. If I multiply by 1/2 again, it got smaller. If I multiply by 1/2 again, it gets smaller. It gets smaller each time. So we want to look at things that are either getting bigger and bigger each time or smaller and smaller. If you just take 1 times 1, and then times 1, and then times 1, it's not getting bigger or smaller. So it doesn't fit the pattern we're looking for this week. Okay? So we're always going to have a positive number, but we won't have the number 1 in the B spot.
You guys, you have that little, like on your notes there, with the box with the y inside of it, the equal and the x. If you want right now, there's arrows coming out of the y and the x. You can just put stays as x, stays as y.
So yeah, just like when we write y equals mx plus b equations, your job is to figure out the m and the b. You have to find the slope. You have to find the y-intercept. But you never change the x and the y. Same deal here. You're never going to change the x and the y, but it's going to be your job to figure out the a, and it's your job to figure out the b. And we'll talk about how you do that. Some pretty really straightforward rules for figuring it out.
Nick, the only time we're gonna have you like, I wanna show you the different things. Yeah, go ahead, you can go to the next problem, David.
So here's an example of an equation. Y equals 3 times 2 to the x. If you look at this equation, which letter there is A, or which number is A? The 3. And which letter is B? It's the 2. All right. How about here? Which one is A? 4. And which one is B? Half. These graphs are going to look very, very different. Not because the 3 and the 4 are different. That makes them look a little different. It's really this number right here and this number right here. Okay? That's what's going to make them look totally different. One of them is bigger than one of them is smaller than one. Okay, so one of them is going to look more like the graph in red, one of them is going to look more like the one in blue.
Guys, wasn't that like we did like the graph and the line, like y equals mx plus b, and we said, okay, identify the slope, identify the y-intercept. We're not gonna make you do that with these. We wouldn't give you something that says like y equals 3 times 2 to the x and say identify the a and identify the b. We wouldn't do that.
So we're going to use this function formula kind of in 3 different ways. Sometimes what's going to happen is they're going to give you a table of numbers like that. And they're going to say, okay, look at this table of numbers. We're going to try to find a pattern in it. And if we can find a pattern, we're going to write a rule for it. Write a rule means describe the pattern, right? And how do we describe it? Well, we're going to use the formula y equals ab to the x.
Say we were given like given a graph of a line and say, okay, put it in slope intercept. I mean, obviously we're not going to have a graph, but same idea. You have to write out some type of equation.
Now, the second thing we're going to do is they may say, okay, here's the formula. Don't worry about coming up with it yourself. We're just going to give it to you, but draw a picture of it. Basically do what I did on the calculator right here, but we're going to do it by hand, right? So that involves me plotting a few points and then connecting them. But if you have an idea of these pictures, this pretty much tells you what every graph is going to look like this week. It's either going to curve up to the right or it's going to curve down to the right. We're not drawing things that are like a straight line this week. Okay. And then the other thing we might do is compare two graphs. Okay. There's lots of different ways we can compare them. We're going to focus on like one thing. Right?
Yeah, we won't ask you you won't have to graph both exponentials and then compare them. We'll give you one rule and we'll say, okay, compare it to this rule.
Like something like this. There's the graph of, let me just actually put something in nice. There's the graph of 2 to the x and the graph of 3 times 2 to the x. I want to know what the difference is. I basically want to know what is that 3 going to do, right? And we'll talk about what it does, and there's kind of a certain way you write what it does every single time, okay?
Kind of like when we did when we graph those absolute value equations, like when it's stretched it vertically, we use stuff like that. It's going to kind of be like that.
Yep, exactly like that. Okay, so that's the 3 things we're going to look at. So, first of all, exponential functions are non-linear. Look at the word you see right there. Line. Right? Exponential functions are not lines. Right? And I've shown you pictures. They curve. Okay, so non-linear means that they curve. They're not straight. Okay? That's an example of a linear function. You guys told me this earlier. Y equals mx plus b. Right? Now,
guys, another reason why we know that's linear is because there's no exponents, right? There's no numbers as exponents. There's no variables as exponents.
So we're going to look at linear, and let's look at a table and see what kind of pattern we get. And then we're going to look at an exponential. We'll look at the table and see what kind of pattern we get. So look at my x's. Okay? You can choose whatever you want for x's. We usually choose x's that go up by 1. Because if you do that, you can see the pattern easier. So we started with -2, -1, 0, 1, 2. Does everyone see we just picked numbers that went up 1 each time? Now, if you pick numbers that go up 1, well, they could go down 1 sometimes, but usually it's up 1 each time. Let's look at what happens to the y values. Okay? What's 3 times negative 2? Alex? 3 times negative 2?
Negative 6.
Plus 2.
Negative 4.
Negative 4. So all we're doing is plugging that number in for x and seeing what we get for y, and we're going to look for a pattern. Nicole, what's 3 times negative 1? Plus 2? Negative 1. Ryan, what's 3 times 0? 0 plus 2? 2. Okay, so we just went through, we plugged them in each time, and now look at the pattern. Negative, how do you get from negative 4 to negative 1? Oh, you add 3. How do you get from negative 1 to positive 2? Plus 3. How do you get from 2 to 5? Plus 3. 5 to 8? Plus 3. So what do you think the next y value would be? 11 plus 3. The point is you're plussing 3 each time. Okay? Any question on that? So you're adding the same number to the y value each time. Right? And that's basically what I'm saying right here. As your x's go up by 1, plus 1, plus 1, plus 1, your y values, you're adding a number to get to the next y value. If you add a number, that's called a linear function. All right? So like, if I made up a table like this, 1, 2, 3, 4, 5. Okay, I don't even have a formula. I have no idea what formula I'm using. But as long as I add the same number each time in the y values, I know that it would be a straight line. Right? Let's start with 0. Somebody give me a number to add each time. 2. 2, 4, 6, 8. I have no idea what the formula is for that problem. But I know if I graph those points, they're going to be in a straight line. Why? Because I did plus 2, plus 2, plus 2, plus 2. I added the same number each time to get from one y value to the next. That makes it a straight line.
You guys, that number you're adding by is the slope. Because it's constant, right? That's what's making it change. That's going to be your slope.
All right, so now let's look at this one. This is an exponential. Okay, this is y equals a times b to the x. All right, so for my x values, you can pick any x's you want. Usually we start with -2 and we go up by 1. That's the key though. To see the pattern, your x's have to just go up by 1 each time. Now let's plug them in and look what happens to the y's. Okay. The first one, 3 to the -2. That's what we did in the warm-up. That's 1 divided by 3 to the second. That's 1 divided by 9. Doubled. So 2 divided by 9. Right? Let's look at the next one. 3 to the -1. What would that be if I did 3 to the -1? Back to the warm-up. What is it? No, remember this doesn't mean it's a negative number, it's a negative exponent. So how do you fix something like that? Flip it. So what's 3 to the -1? Yeah? 1 over 3, yeah. 1 over 3. But then it's 1 over 3 doubled. So 2 over 3. How about 3 to the 0 power? This was something special last week. Anything to the 0 power is always what? 1. So 3 to the 0 is 1. Doubled. 2. All right, let's do the next one. 1. What's 3 to the first power? 3 times 2. 6. And then the last one, 3 to the second power. 9. Doubled. 18. Now, look at your y values. And sometimes it's easier to focus on these to see the pattern because with the fractions, some people have a harder time. But if you can find the pattern with the nice numbers, it's the same pattern with the fractions. How do you get from 2 to 6? Times 3. How about plus 4? Would that get me to 6? Yeah, but that won't get me to 18, right? You got to do the same thing each time. So yes, you could say, yeah, you plus 4 here, but then did you plus 4 again? No. So 2 to 6, you get a times 3. How'd you get from 6 to 18? Times 3. So the pattern here is times 3 every time. So big difference. Times, 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 times. If you multiply by the same number over and over, and you look at your table, that tells you that it's one of these curved functions. Okay? If you add the same number over and over, it tells you it's a straight line. But if you multiply over and over, it's a curved one. It's exponential. Okay? And if you forget, just think about how big that gets. Watch what happens when you times 3 times 3. Look how fast look how huge that's getting just by timesing by 3 each time. I mean, I only pressed it like 10 or 11 times and it's already up to in the millions, right? Press it a few more times, now it's already in the billions. So think of it that way. When you multiply by a number over and over, it gets really big really fast. So it curves up. Okay? So any question why this table is exponential? Okay. We multiplied by the same number over and over. All right. So now, if I give you guys a table, how would we write that as a formula? Well, the first thing is to recognize that pattern I just showed you, that you're multiplying by the same number over and over. Okay? That number that you're multiplying over and over and over, let me give you a hint, it's one of these letters. So our goal is to figure out both of these. Well, if you can figure out the number you multiplied by over and over, you already figured out one of them. I'll tell you which one in a second. So, the underlined part that's highlighted in yellow, that's the part you guys want to write down. This is telling you how to find A. A is not the number that you multiply by over and over. It's not that one. A is the value of the function when you plug in 0 for x. A is the value when you plug in 0 for x. So all you have to do to find A is look at your table, look at the row with x. Okay, I'm gonna put up the other page at the same time. Look at where the 0 is. It's right here. I circle it just so I kind of know where I'm looking. You don't have to circle it. If you want to, you can. When x is 0, look at the y value. So I'd say, okay, when x is 0, the y value in this problem is 2. When x is 0, y is 2. I just look right below it. And that would tell me what A is. The number that's going to be right here is a 2. Okay, so we just looked at this example. When x is 0, y is 2. That's the A value. The A...
Oh no.
Uh-oh, technical difficulties. Let's... Okay, so in the problem I just tried to show you 3 times, when x is 0, y is 2. That tells me that A is 2. That's the first number right after the equal sign. Look at the formula. The first number right after the equal sign is a 2. That's where the 2 comes from. This 2 comes from right there. That's how you figure out the first number. Now, look at the second number, the B. What's the B in this formula? What's the B in that formula? What is it? 3. What did you multiply by each time to get from one number to the next? 3. This number is coming from right there. All right, so let's write that one down. B is what you multiply by each time as the x increases by 1. So I just added by 1. So b is the pattern. It's what you multiply by each time, 3, 2, whatever it is, as the x's go up by 1. Okay, so A, look at your table, find where 0 is in the x row. Look right below it. There's your answer for A. B, you got to look for the pattern. That's a little harder. You got to find what you multiply by each time. And notice right there, it says multiply. It doesn't say add. So if there you find a pattern where you're adding each time, then that's different. That's not going to be this formula. Okay? That would be like what we did back in the beginning of the year. That's y equals mx plus b. Okay? We're mostly going to look at patterns where you multiply each time. Okay, so let's see if we can write a rule for this function. Okay. First thing I want to write down, I think you guys have to fill in the numbers for that table?
Yeah.
Okay, so you got to fill in those. Can somebody tell me what's the formula? It's not y equals mx plus b. What's the pattern we're using? Y equals what? Yusuf?
I said y equals a times. Wait, what are we using right now?
Yeah. Yep.
Okay, so it's y equals a times b.
Yep. Y equals a times b to the x. And what two letters do we have to figure out? We got to find a and b. And I just gave you the rules on the other page for how to do it. Okay, let's start with the easy one. Let's start with a. How do I figure out a? There's no arithmetic, there's no pattern. You just have to know where to look in the table. Yep?
Would it be x?
Well, it's a number. It's got to be a number.
Would it be like -2?
How about with 0, right?
Okay, so we look when x is 0, and then what? Gigi? 2. Find your 0 for x, and then look down and tell me the y value when x is 0. Okay, so x is 0, the y value, 2. That's A. All right, so in a minute, that's going to go right there. But now I need B. How do we get B? What do we have to look for to do that? Ellie?
What you multiply each y value as x increases by 1?
Yeah, what you multiply by each time. So for this, you have to look at the pattern. Okay? If you get stuck with the fractions, I would say just look at the numbers that aren't fractions. If you can find the pattern there, you're okay. So how do you get from 1 to 2?
You plus 1.
Okay, so you plus 1. How about from 2 to 4? Do you plus 1?
No.
No. So if you're not adding the same thing over and over, then we can't do it by adding. You've got to do the same thing each time. So let's try something else. What's another way to get from 1 to 2? Yep? All right, let's try that pattern. Times 2. How do you get from 2 to 4?
Times 2.
Times 2. How about from 4 to 8?
Times 2.
There's my pattern. I times by 2 each time.
So 1/2 times 2.
So what's my B value? Oh, Nate? What's my B value? 2. How come?
Guys, it's time. You're timing it by 2.
Yeah, exactly. It's what you times by each time. Whatever you multiplied by, there's your pattern. Now, all you have to do is plug those two numbers in those two spots, and you're done. Don't try to do anything else. Okay? Just leave it like that when you're done. Y equals 2 times 2 to the x. And that's it. If you're thinking, oh, can I do 2 times 2? No, you can't do it. Okay? Reason you can't do it?
Because there's an x.
Because there's an x right there. Alright, so we just leave it. And that's your final answer. 2 times 2 to the x.
We just like don't worry about x at all.
Yeah, remember, we wrote down y stays as y, x stays as x. We don't have to worry about those two. That's your final answer. Okay. Any questions on that? All right. So let me show you something I can do on here. Let me type that in. 2 times 2 to the x.
Really?
What's that? So what I did on the calculator is I just typed in the formula we just came up with. When x is -2, what am I supposed to get for y in that table?
A negative? Wait, no, positive.
Positive what? A half. I don't know if you can see it, but that's exactly what the calculator just gave me, 0.5. Right? When I put in a -1, what am I supposed to get in that table for y? 1. Joe, what about when I plug in 0? This one. Mm-hmm. So I'm doing the same thing I just did on the last two, for the -2 and the -1. So anybody tell me when x is 0, what should I get? Gigi? 2. When I plug in 0, I get 2. When I plug in 1, I should get 4. Look at that, it's working perfect. That means the formula that I typed in on the calculator is exactly the right formula. So when I plug in 2, I get 8. Now, the advantage of knowing that formula is I can predict, well, what happens if x is 6. So I can go further down the table and I can see what would happen to y.
Wow.
So it got pretty big. So that's why I said to you guys, these graphs start to get very big quick. Any question on that? Right. You're not going to have a graphing calculator, so you're not going to be able to plug in the x's and check your answer like that. But I'm just showing you that you can check it that way, but you're not going to need to do it. Okay. Let's try this one. Okay, it's the same problem. Write a rule for the function. What 2 letters do you have to figure out? A and what? A and B. So take like 30 seconds after you copy it, see if you can figure out A, and see if you can figure out B. So let's find A. That's a quick one. Yusuf?
A1.
Yep. A is 1. Look at the 0. Go down to the y value. When x is 0, y is 1. So we got A. B. Anyone think they got B this time? How much? 3. Yeah, that's what you multiply by each time. Again, if the fractions are confusing, just try to find the pattern with the numbers that aren't fractions. Times 3, times 3. You're timesing by 3 each time. So, anyone think they can give me the entire formula?
Oh no.
Yeah?
1 times 3x.
Close. 1 times 3 to the x.
That's what I meant.
Yep. Now, when you multiply by 1, what does that do to a number?
Just makes it go by 1.
Stays the same. So if somebody wrote their answer like this, that's fine too. Alright? If A is 1, you don't have to write it. But if A isn't 1, like it was in the last problem, it was a 2. If you forget to write it here, then you're wrong. Okay? Any questions on that one? Alright. So, let's look at how we graph this. Okay? Graphing can be a little more complicated than a line. Okay? Lines are pretty easy. You got something like this. find a point, just draw a line through the 2 points. Well, when things curve, you need more than 2 points. Okay? We're usually going to do about 5. Okay? By doing 5, we're kind of going to get something like this. And that kind of gives us a good amount of points to make a curve. Now, under step 1, we're giving you a suggestion of what to plug in for x. Technically, you can plug in anything you want. The problem with exponential functions is the numbers get very big. So if you picked a number like 6 or 7 for x, remember what happened in this table when I picked 6 for x? Y was 128. That's a pretty big number. That's going to go way off your graph. Okay. So our suggestion is to pick these numbers for x. They're not too big. They're pretty small. They're easier to work with. But what's really important, you want to make sure you pick numbers that go in a row. Technically, could you do like 0, 1, 2, 3, 4 if you wanted? You could, but by the time you get to 4, your graph is going to be a very, very big number. Okay. After you plug in those numbers for x, you're going to plug in these 5 numbers one at a time. You have to solve for y each time. This is where being good with the negative exponents is going to come in. Okay? Because the first couple x values that you plug in are going to be negative exponents. Okay, so remember the rules for that. Now, once we've plugged in our x's and we've calculated all the y's, we're going to make a column. Okay? Why are we doing this? This step isn't really a calculation. It's more of a step to just kind of organize all the numbers that you've calculated. So if sometimes you're going through a problem, you get kind of confused, you're like, I don't know what I'm doing, this is to help you organize all your information. Okay, so you're going to fill in an XY column. The x's are going to have the numbers -2, -1, 0, 1, and 2. That's where the x's are going to be. The y's, where are those going to come from? Step 2. So whatever you get for the y values in step 2. Now, the last part, once you have all these coordinates, right? All these x, y's, plot them. Okay, on the homework, we've already got a piece of graph paper printed on there. Same deal on the test. Graph paper is already printed on there. So plot the points and then connect them. Remember, it should look curved. Okay, so same way that I showed you guys how to graph them on the calculator, that's pretty much the same picture we're going to come up with right now. Except we're going to do it by hand. Does everybody have the four steps? Just step 4? All right, I'll leave that one up there. Okay, so on your guided notes, you are going to have to make, I don't think this table is already printed. So you'll just have to make it. It's not printed on there, is it?
No.
No, you got the graph paper printed, but just not the table. So the first column is going to be x. Second column is going to be y. What numbers did I suggest you do for x?
-2, -1, 0, 1, 2.
Yep.
There you go.
Now, again, you don't want to use those numbers? Fine. Use whatever numbers you want. But I'm telling you, if you use big x's, you're going to go way off your graph. It's not going to work nice. Now, what do I do with each one of those numbers? What do I have to find now? Yeah?
Solve for y.
Solve for y. We're going to take each x value, plug it in, and solve for y. All right? So first x value I'm going to plug in is negative 2. So off to the side, I'm just going to do it over here. Negative 2, I plugged it in for x. What's 3 to the negative 2?
6.
1 over 3 to the second.
Is 9.
1 over 9. Yep.
Yes.
So y is 1/9. All right? What's the next number I plug in for x? Negative 1. What's 3 to the negative 1? Remember, negative exponents don't mean negative numbers. 1 over 3. A negative exponent does not mean a negative number. It means put it in the bottom. So 1 over 3. Right? What's the next number for x?
0.
0. If I plug in 0, what's 3 to the 0?
0.
1.
Wait.
1.
Ah.
Okay, remember, anything to the 0 power is 1. Okay. Next x value? 1. What's 3 to the first power? 3. See, it gets easier as you go because now we're not doing negative exponents.
And then it's 5.
3 to the second power?
Oh no, it's 6.
9.
Bruh.
I'm bigger.
Okay, remember, when you plug that in, you're not multiplying 3 times 2. Question? Sure? So 3 to the second power is going to give me 9. All right, I got all my y's. Now what do I do?
Graph it.
Not yet.
Make it the coordinates.
Make the coordinates. Right now I just got a bunch of numbers. Make these coordinates. What's my first coordinate?
Negative 2, 1, 9.
That's it. Just copy them down. Second coordinate.
Negative 1, 1/3.
Negative 1, 1/3. Third coordinate.
0,
0, 1. Now we're getting into numbers that are a little easier to graph. Next coordinate.
1, 3.
1, 3. Last coordinate.
2, 9.
2, 9. All right. Negative 2, 1/9. Is 1/9 a big number or a small number?
Small.
Small. Is it 0 though?
No.
Not quite. It's a little above 0. Are you going to be able to graph it exactly at 0.1?
No.
No. So, negative 2, 1/9, I would just draw it like this. Negative 2, 1/9, just put a dot just barely above 0. The next one is negative 1, 1/3. Okay. Is 1/3 bigger than 1/9 or smaller? It's a little bigger. Okay. Negative 1, 1/3. It's like 1/3 of the way up, so a little bit bigger. What's my next coordinate?
0,
0, 1. Now I think if you look at it, you can just start to see the curve. Right? What's my next coordinate?
3.
1, 3. Now we can really start to see the curve.
Oh, yeah.
It's going to go up quick. My last coordinate?
2, 9.
2, 9. If you had gone any bigger with your x's, you would have gone off the graph. You wouldn't have had enough room. I think you guys have a graph that's a little bigger than mine, but still, you couldn't go that much bigger. So this is what your graph should look like. All right? Draw your line. Have it stay very close until it gets to here. And then have it curve. Okay. And that's what your graph should look like. Any questions on like how we got these y values, how we graphed it? What's that here? You all set? You seem a little distracted. A little excited. You must be excited for the homework, right? Yeah. That's all. Alright, so any questions on that graph? Alright. Let's try this. So the last thing we're going to look at is how do you compare two graphs, right? Like, if I gave you this one, and I gave you this one, they're very close. They both have a 2 to the x and a 2 to the x. What's different is the number in front. One's a 3, one's a -3. Well, there's a certain way that you explain how they're different, okay? And that's the last thing we need to look at, okay? The only thing that's really different is one's a positive and one's a negative. That negative does something, okay? So let me graph it and show you how they compare. Okay. So without going through everything we just did, here's the graph of 2 to the x. Okay. I just did it on the calculator. Just like the graph I just did in green. Where did I do it? Right there. Okay. That's 3 to the x. This is 2 to the x. If you wanted to do it by hand, you'd make your table, pick your x's, find your y's, graph your coordinates, draw your sketch. All right? So there's 2 to the x. Now, let's look at 3 times 2 to the x.
Wow, that's a big difference there.
What's the difference?
I
Oh, you tell. So go ahead. Tell me what's the difference.
don't know, I need to look at the last one to be honest.
Yeah, I know.
One goes down, one goes up, and then the other one.
Yeah, what's the difference? The one in blue is the original, and the one in red has the 3 in front.
One has a sharper tone.
Yeah, one of them starts to curve up sooner, okay? And the way you can kind of visualize what happened is, pretend like this one in blue, right? Pretend like that's a, like something that's, I don't know, flexible. Like maybe a piece of spring steel, or could even be like rubber, whatever you want. And imagine the one in blue is glued down right there. Okay? Well, if you take that one in blue and you pull it up, okay? Take the one in blue and pull it up. But again, it's glued down at that spot over there.
So you can't
So
really do much.
what would happen is if you pulled on the one in blue straight up, it would turn into the one in red. That's what would happen if you pulled it up. So what we call that is it's a vertical stretch. How much did it stretch
Oh,
by?
I heard this one before.
Yep, we've used this before when we talked about absolute values.
Oh, yeah.
Oh yeah. Very difficult.
Actually, no.
That's just
So
That's all that matters.
when you put a number in front, that causes your graph to imagine, like I said, it's glued down right there, it stretches it up. Okay, imagine it like pulls it up. Now, what happened there?
It went like across
not today.
If you had to describe that one from blue to black in one word, what happened? The blue one did what? It,
Went up.
I wouldn't say it went up. Okay, because it did what? It went upside down. So it, I would say flipped. I'd say it flipped. Right? It flipped over.
like we did last time.
So when you have a graph that's like the one in blue, okay, it flips. Okay? It flips. What made it flip?
The negative.
The negative. All right? So there's two things that can happen. The negative can cause something to happen, and the 3 causes something different to happen. The number causes a stretch. The negative causes a flip. So we're going to write down those two things. Not every problem is going to have a negative. If it does, then it flips. If it doesn't, then it doesn't flip. Okay? So, when I ask you guys to compare exponential functions, okay, if a is greater than 1, okay, the graph is stretched vertically. Okay, that's what happens. The graph stretches vertically. It doesn't flip. It only flips if it's a negative. Okay, we're going to write that next. This is how you write it. You would write on the test, vertical stretch by a factor of and then you put the number that's in the place of A. So like in the last problem we just did, vertical stretch by a factor of 3. Now, if it had the negative in there, we haven't talked about that yet. I showed it to you, but I didn't tell you how to write it. I'm going to tell you that next. So, if A is negative, now you could have two things happening. Not only are you going to get that vertical stretch, but the negative will also cause the graph to flip, right? Or some people say like a mirror image, it's a reflection. And which way does it flip? It flips over the x-axis. So imagine like, let's go back here. Imagine that that was a piece of paper, okay, and you fold it on that green line. If you folded it on the green line, your graph would look like this. Instead of going up like that, it would go down. That green line is the x-axis. That's how it flips. Okay. So, when you have...
There's not really much you can do that.
Yeah, not much I can do. I can't make it bigger. So, it says written like, and then it says vertical stretch by a factor of A. That part stays the same, but you have to add one more thing. And it's reflected over the x-axis. Okay, reflected over the x-axis. Now, if the number is a negative, don't say that it stretched vertically by a factor of -2. No. If you stretch something, it's always a positive number. The way you describe the negative is to write this last part. Reflected over the x-axis. That tells me there was a negative in front. Okay? So, A is bigger than 1, doesn't reflect. A is negative, it does two things, stretches and reflects. Now, if A causes it to stretch, what do you think happens if you keep putting in a bigger and bigger number for A? Stretches more. It can stretch a little bit, it can stretch a lot. Okay? If you make A 20, it's going to stretch out 20 times as much. If you make A 2, it's going to stretch out a little. It's going to stretch out twice as much. Okay? So the bigger number you put for A, the bigger the stretch you get. Now, what happens if A is negative? What happens if you put in a negative number for A? Right there. Causes the graph to reflect over the x-axis. Okay? So, let's look at this one. Now, when I ask you guys to compare two graphs, these two things will always be the same. If those aren't the same, you can't do it. Okay? It's just the number in front that's going to be different. So, look at the first one. That one's right here. Let's move that off. What's A in that first one? 4. What's A in that second one? 1. Technically, if you want to put it in, there's a 1 right in front. When it's a 1, you normally don't see it written. Okay? So I'm just going to leave it off. So I want to compare these two graphs. Is there a flip happening? Like if you were to make the table and draw it all out, why? Why isn't there a flip? Yep. There's no negative. So what's the only thing that's actually going to happen? The 4 causes a stretch. Now, how did I say to write the answer? It's a blank. There's a way you write it every time. You just change the number. Gigi?
Vertical stretch by a
vertical stretch by a factor of 4. Okay, vertical stretch by a factor of 4. That's all you have to write. What does that really mean if you drew it? It would curve up sharper. Okay, I showed you that. It would curve up a little bit sooner because you stretched it out.
Is that like your answer, like your final answer?
That's how you write the final answer. Yep.
I see a negative.
Alright, how about this one? What's b in both of those equations? 4. B is 4. B has to be the same to do this kind of problem. Okay? 4 to the x, 4 to the x. What's in front of the 4 to the x in the first one?
-3.
Two things. A negative and a 3. I want you to think of those two things as separate. Okay? What is the 3? Forget about the negative for now.
Thank you.
Tell me what the 3 is going to do. Tell me what it's going to do. Yep.
It's gonna make the like a line, like a
So I'm looking for 2 words. It's going to blank blank. Or you could actually just, yeah, 2 words really.
Reflect over x-axis.
No, not the 3. The 3 will not cause a
But it's a
reflection.
negative 3 though.
The negative will. We're going to get to the negative next.
Oh, this is 3 because it's have a sharp turn.
What's the 3?
Okay.
Okay, it's going to have a sharper turn because it's going to cause the graph to stretch, vertically stretch. That's what I was looking for. The 3 causes a vertical stretch. How do I write that as an answer, Donovan?
3 causes a vertical stretch. I don't know. I should ask Joe. I don't know.
Did you write it down on your notes? So look back at your notes. I wrote written like, and then I put a set of quotes, and I told you what to write. We did if A is greater than 0, written like.
And like or written like?
Written like.
Written like.
Written.
Vertical stretch by factor of 4?
No.
3?
3. So vertical, very good, stretch
Thank you.
by a factor of 3. Is that it though?
No.
No, now Winnie, what did you say about the negative?
The negative is going to be the reflection, so if you reflect it over
And how do we write it? Reflect over
the x-axis.
x-axis. If you wrote this, I'd give you half. You told me that it stretched, but you didn't put the negative. You didn't tell me about the negative. So vertical stretch by a factor of 3 and reflect over. If you don't want to write reflect, you could write flip. Means the same thing. Reflect over x-axis.
So that's the final answer?
That's the final answer right there. You have to write exactly that.
That's the final answer.
Okay, a couple quick reminders before I give you guys homework. Homework tonight, it's going to be a worksheet. Test on Friday, second to last test for the term. I will be after school and Mr. Roy will be after school on Thursday. Last day of new material is next academic Monday. Okay? Okay. Thinking ahead, we have our math final, June 6th. Okay? That's a Friday, which means we have the whole week to prepare. If you have classes where your final is on like a Tuesday, you're going to have your final early in the week. You're probably not going to have as much time. We have Monday, Tuesday, Wednesday, Thursday to review for the final. Correction, June 6th is a Thursday. June 6th is not a Friday.